Recursive descent parser. Recursive descent parser is a top-down parsing technique. So in this technique, the parser implements recursive procedures, that is subroutine, to parse the input string. This procedure is associated with each non-terminal of the grammar. Input will be scanned from left to right, and during left to right scanning of the input, if the parser identifies a non-terminal, then a recursive procedure will be implemented to apply the production rule for the non-terminal. If the parser identifies a terminal, then the terminal symbol will be compared with the look ahead symbol to check whether it is matching with the input string or not. If the terminal is not matching with the input string of the parser may need to apply the alternative production rule. In that case, it may need backtracking to identify and apply the correct production rule. Since the recursive descent parser is a type of a predictive parser, to the maximum possibility, the predictive parser tries to avoid backtracking or infinite loop. It always predicts the right production rule to apply for the non-terminal. Only in worst cases, it may require repeated scan over the input or backtracking. Steps in recursive descent parser. Initially, the procedure begins with the start symbol of the grammar. In every step, the parser will scan the input from left to right to identify whether it is a terminal or non-terminal. During scanning, if the parser identifies a non-terminal, it will recursively replace non-terminal with production by checking with the next input symbol, that is look ahead. If more than one alternative production rule is available for a non-terminal, then decision is based on the comparison with the look ahead symbol. That is, the starting symbol of the production rule should match with the look ahead symbol. If the parser identifies a terminal and matching with the input string, advance the pointer to check with the next input symbol. This procedure continues until it derives the entire input string. During this procedure, in any case or step, if it doesn't match to derive the input string, apply backtracking. So recursive descent parser is nothing but the procedure begins with the start symbol of the grammar, and whenever after starting with the start symbol of the grammar, the parser starts scanning from the input from left to right, and it will check whether it is a terminal or non-terminal. If it identifies any non-terminal, then it will replace the non-terminal with the next terminal symbol. So with this example, you will understand clearly. So consider an example like S tends to AB or BA or epsilon, A tends to A or BS, B tends to B or AS, and the string we need to derive is AABA. So I'm constructing the parse tree for this. S tends to AB and B tends to AS, B tends to AS, S tends to BA, and A tends to A. So we have derived the given input string AABA. So the advantages in the recursive descent parser is it is a simple method. It is easy to construct a parse tree in this method, and the disadvantages are the recursive descent parser implements the recursive procedure for every non-terminal to implement the production rule. It will be considered as the slower procedure. If the parser produces the error message, with the help of the error message, it is very difficult to diagnose the error and rectify that error. If the input string is a lengthy input string, it is very difficult to parse the input string. It is not suitable for all the types of grammars. So consider an example here. E tends to E plus T or T tends to T star F or F tends to E or ID. So first, in order to do the recursive descent parser, the first thing is you need to remove the left recursion. So to remove the left recursion, first what we need to do? how we need to check whether it is left recursive or not? If to the left hand side and right hand side the starting symbol we have the same symbol, then it is called as a left recursive production. So in order to eliminate the left recursive production, the first step is we need to write the non left recursive productions. So E tends to, here the symbol E, and here also we have the symbol E. That means E tends to E plus T. This is a left recursive production. And here we have or T. So this is the non-left recursive production symbol. So the first step is we need to write all the non-left recursive symbols. That is E tends to T, and then introduce a new symbol, that is E dash. We need to introduce a new symbol related to the starting symbol. So this is the first step in order to remove the left recursion. And now for E dash also you need to derive this. And the second step what we need to do, E dash tends to, we need to write the remaining productions from the left recursive production except the starting symbol. So except E we need to write the remaining symbols. So the remaining symbols here are plus T, and write this, the newly introduced symbol, that is E dash, and then write epsilon. So this is how we eliminate the left recursion. So for the first for the first production we have eliminated. In the same way we need to eliminate for this also. T tends to T star F or F. So it is written as T tends to Ft dash, and T dash tends to star Ft dash or epsilon. And here in this production we don't have any left recursion, so we can write as it is, F tends to E or Id. For recursive descent parser we are going to write one program for every variable. So consider an example, E tends to IE dash and E dash tends to plus IE dash or E. So we need to write the program like int main flower braces. So first what we said, it starts with the starting symbol, that is E, and if look ahead is dollar, it represents the end of the string. So for every end of the string we need to represent it with a dollar. So if I equal to dollar, here I is called as the dollar. If I equal to dollar, that is, then we need to write printf parsing successful. Then again as per the given production for E we are going to write the program E, if I equal to I, that is if I, that is the look ahead symbol, equal to I, then match I, and then write E dash. Then next again according to this we need to write the program for E dash. So E dash if I equal to plus. So here the starting we have as plus. If I equal to plus, match plus, and the next match I and E dash, else return, or match character T. If I equal to T, I equal to get char, else printf error. This is how we write a program for the recursive descent parser. For every variable we are going to write a program in the recursive descent parser. That is nothing but it should match with the look ahead symbol. Like if there is any non-terminal, that non-terminal will be replaced with the next terminal, that is called here as a look ahead symbol.